Hi! In this tutorial, we are going to make a Parachute of Battle Royale game. First, import the parachute mesh and textures in the link. When parachute mesh is imported, a white material will be applied. Click the white material to open a window and connect the imported textures according to their names. Next, click the third-person BP to open the character blueprint window and drag parachute mesh to character to create components. Reset the parachute's rotation and position. After resetting the parachute, uncheck Visible of Rendering to hide it. Next, make an event tick node and create a bool variable. Next, create a branch node and connect it to the event tick node. Then create a bool variable in the form of get and connect it to the branch node. After dragging character movement from the component window, create an air control and gravity scale node in the form of set from the drag node. And set the values of the air control and gravity scale nodes as in the video. Then, connect the air control and gravity scale nodes to true on branch. Next, create a set velocity node in character movement and connect it to the gravity scale node. Next, create a get velocity node, and then create a break vector node and a make vector node to connect each other. Set the z value of the make vector node to -300 and connect it to the set velocity node in order to reset the falling acceleration. Next, copy 3 nodes and connect them to false of branch. And reset the values of the copied nodes as their original state. This completes the setting of the falling speed. Next, let's set up the camera. Create 2 custom event nodes and name one zoom in and the other zoom out. Next, create a timeline node and click it to open the timeline window. Set length as 1, create a float track, and set timeline as in the video. Click the first curve, right-click, and click Auto to create a graph of a smooth line. Next, connect the two custom event nodes to the timeline node. Next, drag the camera boom node and create a target arm length node as the form of set from the drag node. Now if you connect the timeline node and the target arm length node as shown in the video, the zoom function of the camera is activated according to the custom event call. Next, create a keyboard node and set the desired key. Next, create a branch node and connect it to the keyboard node. Drive the bool variable and connect it to the branch node. Then create another branch node and connect it to false of the previously made branch node. After that, drag character movement and create an is falling node from the drag node and connect it to the branch to check if the character is falling. Create a do once node and connect it to branch's true node in order to make the parachute executed only once. Then get the bool variable in the form of set it to true, and connect it to the do once node. Next, create an event on landed that executes an event when it touches the ground. Then, get the bool variable in the form of set it to false, and connect it to the event on landed node. And create a do once node and connect it to the bool variable, so make it run only one time. Next, call the previously created zoom in and out nodes and connect the nodes like the video. Then, drag the parachute component to create two set visibility nodes. Like the video, set visibility connected to the zoom in node is true and visibility of zoom out is false. Now that parachute's switch function is completed, let's make movement and rotation in parachute state. Go to the movement input that was previously created in the character. After creating a branch node, load the bool variable and connect it with the branch node. Then connect the input axis move right node and the branch node and connect the branch's false node to the add movement input node. After that, create another branch node and connect it to the true node of the previously made branch. Next, create a less than node and connect it to a branch in order to determine the left side of the movement. Then create another branch node and connect it to the false node of the previous branch. Then create a greater than node as before and connect it to the branch node so that we can determine the right side of the movement. Next, create two sequence nodes. Connect one of the sequence nodes to the branch node, which determines the left movement, and the other to the branch node determining right movement. Next, create two float nodes and name them actor rotate and rotate speed respectively. Next, create a branch in the upper sequence and connect it. Then, after importing actor rotate in the form of get, create and connect a less than node, and set the limit of the actor rotation by setting the value. After setting, connect to the branch node. Next, bring the actor rotate in the form of set and connect it to the false node of the branch. Then, create a set actor rotation node and connect it to actor rotate. Next, create a get actor rotation, known to receive rotation values from the actor. Then create a break rotator and a make rotator to connect Y and Z nodes except X. After that, connect the X of the break rotator to the actor rotate node in the set form. Create a subtraction node, set the value, and connect it to the both actor rotate node and make rotator node. Lastly, connect the make rotator node to the set actor rotation node. Create and connect a get rotation X vector node by dragging a pin from the make rotator node. Then, copy the add movement input node and connect the get rotation X vector node. Next, copy the set actor rotation created earlier and connect it to the sequence node. Then, copy the break and make rotator nodes previously connected and connect them to get actor rotation. After connecting X and Y of the rotator nodes and getting the rotate speed in the form of get, create a subtraction node and connect it as shown in the video. Connect the set actor rotation node created earlier to the add movement input node. Next, create a branch node and connect it to the add movement input node. Then create a timeline node and click it to open the timeline window. Set the timeline length to 0.5, create a float track, and set the timeline as in the video. When the timeline setting is completed, connect the branch node to the timeline node. Next, duplicate the Set Actor Rotation node and connect it to the timeline node. And explode the pin that created the Get Actor Rotation node. Then connect the Timeline node and the Get Actor Rotation node to each other by creating a multiplication node. Next, create a Make Rotator node and connect the nodes like the video. Lastly, after creating an Actor Rotate node in the form of Set, connect the Actor Rotate node to the finished node of the timeline so that the rotation value can be initialized when the animation is finished. Next, after getting Actor Rotate in the form of Get, create an Absolute node and connect it to Actor Rotate. And after creating a multiplication node, set the value to 0.3 and connect it like the video. Next, create a less than node by dragging a pin from the previously made absolute node and connect it. Set the value of the less than node to 1 and connect it to the branch node. As in the video, copy the nodes that made the motion before and connect them to the sequence node that has not been connected yet. While connecting, all previously created comparison or calculation nodes are set to the opposite form or opposite value. Just replace the negative nodes with positive nodes as shown in the video. And connect the branch node at the end of the copied nodes to play the start of the timeline. The implementation of movement during fall is now completed. Save and exit to the content browser. search for the cube in the content browser and place it in the level. Next, set the Z value of the cube high to make its place to fall. And place the player on top of the cube. Now, when you play and jump and press the key you set, you can zoom out and see the parachute unfold and fall. The movement is a bit awkward. To fix this, let's go back to the character blueprint. Copy the Add Movement input, which is connected to the Move Forward node. After creating a branch node, create a bool variable in the form of get and connect it to the branch node. And connect it to the branch node as shown in the video. Next, create a Get Actor Rotation node. Then create a Get Rotation X Vector node and connect them together. Next, connect the Get Rotation X Vector node to the Add Movement input. Next, create another branch node and connect it to the previously made branch node. After that, create a less than node, set it to 1, and connect it to the branch node. Lastly, create a multiplication node, set a value around 0.8, and connect the nodes like the video. Next, set the default value for rotate speed as 1. Now when you play, you can see a smooth fall